Piero, APP and data science fellow at CBS, and then we have Viren, a senior machine learning engineer at CBS. And in this talk, we're going to have talk about lower code ML pipelines and Conduit.
All right. Thank you, everybody. My name is Piero. This is Viren, as mentioned. I'm an AVP of the ML platform and data science fellow, and Viren is a senior machine learning engineer on the machine learning platform team. So, wanted to get to know a little bit about the crowd. So, who here works with Python? This is a Python conference, so presumably everybody in the house, okay? Data scientists or machine learning engineers, keep your hands up. Model developers, okay? Who deploys models to production, okay? And who thinks that deploying models to production is trivial? Get out. All right, so post-model development, what do we really care about? Developing models is all well and good. I'm in my notebook, I'm having fun, I'm importing libraries, I'm playing around with different things, exploring data. I've now developed a model, and I presumably developed this model for a reason, to solve some business problem, to hit some evaluation metric, and now I need to, I've satisfied those criteria, and I need to move something to production. What do I do now? Now you have to start thinking about these second-order problems. Problems like orchestration, problems like my AI infrastructure, problems like MLOps. And these are the non-trivial aspects. Typically, we look for characteristics like reliability and scalability and maintainability when we're thinking about distributed systems. When we're thinking about machine learning ops, we'll often talk about reproducibility or explainability guarantees. So we're in the United States. Over in Europe right now, they are companies that are doing machine learning and artificial intelligence are subject to regulation. And if you're reading the winds right, that is going to change in the United States, presumably pretty soon. So it behooves us as practitioners to be well in front of that. And along the way, we should be developing good, reliable software to the best of our ability as well. So, bearing all of that in mind, has anybody ever seen this picture before? It's a crazy one. Right? First Mark Capital, they do this inventory of all the tools in the ecosystem every year. And the long story short here is that the ecosystem is crazy crowded, right? There are so many different solutions for platforming and pipelining and you name it. Here I just blew up a couple boxes for like the MLOps solutions, the AI infra and orchestration solutions. But we're not necessarily wanting for optionality at this point. But the question is do any of these things really satisfy all of those needs really well? So building from there a little bit, remember when we have our data scientist hat on and we're developing a model in a notebook like most of us do, and then you get to that point where it's good enough and you want to move it to production. Well, what next, right? We can talk about refactoring your code, we can talk about learning a workflow platform, we can talk about DSLs. Yes, there are ways, obviously, but it bears asking the question, could that be easier? Is that time well spent for a data scientist to learn all of those things? Now, there are some really promising projects that I'm particularly excited about in this area, notably LineaPy and Plumer, and they're seeking to address that problem of give me a notebook and I will give you a pipeline or parts of a pipeline right back out. TensorFlow is a little bit of an oddball here, but TensorFlow is just such a massive library that not only do they have deep learning architecture, you can build all sorts of simple machine learning models, complex machine learning models, but you also have TensorFlow extended, the ability to express kind of pipelines or directed graphs of tasks in TensorFlow as well. So if we agree that this is a problem or an unsolved problem in the industry as practitioners going from notebook to hardened production pipelines, let's consider the following. So why refactor if we don't have to refactor? Like, nobody would just refactor for the sake of refactoring. Sometimes you do it because you have to. But typically, refactoring happens when we have a handoff. So my team hands off to another team. And what happens? Just like in kindergarten, when you're playing a game of telephone with your friends, so I whisper something to someone and they whisper it to somebody else, and so on and so forth. Ultimately, at the end of that chain, something gets lost in translation, right? We lose some of the fidelity along the way. Also, as developers and engineers, we're taught dry, do not repeat yourself. So I think we can all get behind the idea that refactoring should be avoided if possible. So from there, I know this meme was already used, but kind of a different one. So the boss is asking all the data scientists, how will we translate our models into pipelines? And somebody says YAML, and then somebody says JSON, and then somebody says, let's actually learn to use the workflow platform well, and then out the window, here she goes. For those of you that can't see the slides or just listening to the audio or something like that, there's this fictitious quote that I thought about. I studied math and programming for 6 years in college, and now I'm just sitting there writing JSON and YAML files, key value files all day long, and that's a terrible existence, right? That's not something that any of us enjoy doing or aspire to do. So the third thing that I want you to keep in mind here, or to consider together, is that locality matters and that the developer experience and ergonomics matter. There's this idea of context switching, and we can debate whether or not multitasking and context switching even works or is effective, but we all do it to some extent on our day-to-day. One study suggested that we spend about almost 10% of our day context switching. I'm working in my IDE, I jump to this tab in the browser, I jump over here, I jump to my second desktop where I'm running my VM, and over here. And ultimately, that's not great. You can't really focus as much when you're jumping from different system to system or context to context. So to tie that back to a data science workflow, I'm developing a model in my notebook, and then I say, oh, this model's great. Let's move it to production. So maybe I convert it to a bunch of Python files, I commit them to GitHub, maybe I pull them down my local IDE, and I start modularizing the code, or I start incorporating some of the code into a workflow platform, turning it into a Airflow pipeline or something like that. But that's a lot. Even that involves a couple different layers of context switching, and we've all just come to accept that as status quo. So the question is can we do better? Should we do better or aspire to do better for some of the data scientists that want to avoid refactoring, don't want to live in config purgatory, and have a bad reaction to all the context switching? Enter stage left, the library textual. Not sure, is anybody familiar with this library textual? Yeah, it's pretty cool stuff. It came out after Rich did, but you can develop these terminal user interfaces that can run right in your terminal, and you can also actually use textual to develop web applications that run in your browser as well. So we wanted to see what was possible with textual, to see if we could take it and use it to solve some of those problems. Again, avoiding refactoring, avoiding living in config files, and emphasizing locality and ergonomics. So we tried this, we did this, and currently we have this terminal user interface as part of the Conduit package that will essentially be used to configure your machine learning pipelines. And Viren will now, well, in a moment, sorry, I forgot I have one more slide here. So with Conduit, there are these 5 easy steps. First, we install the package, then we initialize the repo templating from the command line, and we can copy and paste your machine learning code without refactoring it into some of these templated files. And then you will go ahead and configure a pipeline in the TUI and deploy it. So with deploying these models to production, with this data scientist, it's a profession that didn't exist 20 years ago, really. There's just such a wide range. You have folks that studied social science in college and maybe dabbled in a little R scripting. And then you have other folks that learn to program when they're 8 years old and have a PhD in computer science. And there's a lot in between. As a data scientist who loves to program, I care most about solving problems and creating impact. So time to value, getting my models into production, having them touch lives or inform decisions, it's what's most important to me. So the fact that a tool like this, or other tools if you were at the Metaflow talk earlier, can help alleviate some of that pain, the pain of orchestration, worrying about AI infra, and ensuring that you're following some semblance of MLOps best practices is pretty powerful. And I think anybody who's been at this for a while, we want to avoid the refactoring. We don't want to be robots just working on YAML files all day. And to the extent that we can keep things local and somewhat ergonomic is in our collective best interest. So what's next for Conduit? We want to continue adding components to the component library. So there are more sophisticated patterns. We think about self-healing systems or models that can retrain themselves. My features drifted, my labels drifted. Okay, I'm going to go and grab a more recent window of data and just retrain my models. Readily achievable things, right? Additional components, supporting different frameworks, like Viren mentioned before. We haven't gone really deep into textual, but the terminal user interface can be a lot more beautiful. It can be a lot more dynamic. We just wanted to play with this idea a little bit for some of the reasons mentioned before. Handling more complicated or more sophisticated pipeline assembly, of course, and the hot topic, LLM ops. I don't want to touch it right now because I still think we're figuring out exactly what that means. But when the time is right, when some of those patterns crystallize and the dust settles, I think that's the next area to look at. Presumably our scientists will want to deploy LLM pipelines or agent frameworks as well in the future. So with that, just want to thank all of you for attending today and happy to take any questions that you may have.
So the boilerplate code that you generate, are you guys trying to refactor it into a library or something? Okay. Or is it imported to the boilerplate code to get created?
The components are part of the Conduit library, and then it draws from those components to assemble them into a pipeline based on the inputs that we're collecting through the TUI. So it's a model that's conducive to inner sourcing or open sourcing, because you can bring your component, you can bring another component, and that collection just builds and builds and builds. We also want to reuse each other's components, just like we may want to reuse a model or reuse a pipeline. So like that kind of composability aspect. And I think it encourages the right type of collaboration among teams. Avoid recreating the wheel, let's collectively build a better wheel together. Sure.
Walk me through how to use it. Do you have to be on Vertex? And once you're on Vertex, how do you go about using it?
Yeah. Do you want to take that one?
Sorry, can you repeat that question?
Do you need to be on Vertex to use Conduit?
Yes, currently you need to be on Vertex because, technically the package is a Python package. It's internal right now, but once we open source it, you can download it anywhere you want. However, it generates Vertex AI pipelines, right? And it's kind of going to be deployed on Vertex AI, so you need to.
And how generalizable is that? Like, I guess that's this question. It's like, yeah, is it generalizable across cloud platforms?
Yeah, absolutely. Actually, technically, we make Kubeflow pipelines, right? And as long as your platform supports deploying Kubeflow pipelines, then it's going to work.
Yeah, it's like the idea in the abstract can work on top of anything. Right now, we focus on Kubeflow pipelines because we're working in GCP on Vertex AI. But yeah, it could be extended to Argo. Kubeflow is kind of just like a nice DSL on top of Argo anyway, right? Or Airflow if you're so inclined. I personally like Kubeflow a lot. I think it's future-proof to the extent that things can be future-proof within our industry, like for at least, let's say, like 5 years. This idea that like different tasks within my DAG can have their own hardware and software is like really powerful. So, if we just think about like an NLP pipeline where you're like tokenizing some things, maybe you just need some CPUs, but then you need to do some transfer learning. I want GPUs. So we started with Kubeflow, and we'll probably take that a little bit further, and maybe upon open sourcing, would love to see like how others would like to use it in other workflow platforms that they'd like to support. Yep.
You talked about batch prediction pipelines, it's kind of offline inference. I was curious about whether you have any support for the online prediction or like real-time machine learning model inference.
Yeah, I can take that. Thank you for your question. Yeah. As you saw in the training pipeline, the last part of that pipeline is deploying that model to an endpoint. And that endpoint is scalable and queryable for real-time predictions. The cool thing about it is like you can specify the hardware, the minimum hardware for that endpoint, but then it also auto scales to handle whatever your request size or traffic might be.
So endpoint is kind of a low latency solution?
Yes, it's a low latency solution around, our tests have revealed around like 300 milliseconds latency, which is I think the industry standard.
And that's one of the niceties of Vertex, for example, that they'll scaffold those, they'll scaffold your prediction endpoints. You don't have to like go in there and roll your own fast API or Flask apps. And that's nice, right? We've all done it. Like, have I done it well? Probably not. Like maybe like a B- or B student, like if I had to roll my own REST API. So I think that's one particular nicety of what Vertex brings to the table.
Follow-up question on that, then where do you define like what endpoint you want? Like you have your predict, you have your maybe like pre-processing stuff, right? Is it all just rolled up in one?
Yeah, so I can explain more. Basically, these endpoints and batch predictions all spin up like a server, and there's a server.py file in the backend that we created, right? And that does the predict function. Now, if you have the sklearn API, they have standard predict proba, and we call both of them when they're available. But if you have, and our stance is to roll up the pre-processing in the pipeline in the sklearn pipeline. So in the model object, as long as you do all the pre-processing and then you adhere to that API, the server is going to work out of the box. However, it is customizable because if you use Conduit, we present all the code and it's like editable by you. So if you want to have some like custom functionality and you want to change, what the output of the predict function is, you can go in, change that, and that's going to apply to the endpoint. You're going to get back the type that you want.
One more question.
Yes.
Like, is there a way to coordinate multiple projects? Like, so I noticed that because you create like this repository, and is there a way to have like a connective tissue between two repositories, or they are like isolated, separate things?
Right now, it's kind of like one pipeline per repo sort of thing, and that has more to do with kind of our downstream CI/CD. But there wouldn't be any reason why you couldn't have multiple pipelines or pipelines talking to one another. Like, for example, at the end of one of your prediction pipelines, or after you make predictions, if you want to like put a message on PubSub or something, and then somewhere downstream there's a listener waiting for that message or a cloud function to do something with it. That would be one way to sort of interconnect things if you're leaning into like GCP native stuff, but you know, a lot of like serverless functions will allow you to have that connective tissue. Does that answer your question?
Oh, yeah.
Okay.
Perfect.
Okay, so there's a model logging feature to it. I don't remember if you mentioned like how do you log your data, how to version your models.
Oh yeah, that's a great point. So basically the way the pipeline works is it's anchored on the model name. So if you run this pipeline again through Conduit with the same model name and it passes the evaluation metric, it's going to up version your model. So in model registry, I can go and show you if you want. Each model can have multiple versions, and you can do traffic splitting between them as well. So there's going to be version 1, version 2, version 3. Currently, the latest version becomes the default version, and all the traffic goes to that. But later, once we get into experimentation or A/B testing, we can split the traffic between the models.
And then on the logging front too, that's another area where we're kind of just leaning into Vertex AI. They have all sorts of metadata capture along the way, kind of analogous to what you'd get out of like an ML flow, for example, and you know all the logging that comes with it. So if you were using a different framework or kind of a different stack, maybe you know you need to emphasize that more explicitly. But with our Kubeflow pipelines using some of the Vertex services, it's kind of nicely taken care of for you. All right, I love this second row here.
Yeah.
Lots of great questions. All right, well, I want to thank you again for listening. If you have any questions, we'll stick around, but really appreciate it.
Thank you so much.